Hello? Okay, now this example is for showing you how to use LIFEREG procedure to actually fit different survival distributions, lifetime distributions, such as exponential and Weibull and extreme value distribution for right sensor data and interval sensor data. And also you can use a fixed scale parameter. Okay, so first let us read in this small data set here. It has y-axis and censoring variable. Okay, so read it in, and we really don't need to do the log transformation of y because in the procedure it's gonna do that for us. So here is a chunk of SAS code that calls PROC LIFEREG, but we are going to fit a regression model with only the intercept. Okay, and this is actually we're utilizing the supported distribution within PROC LIFEREG to fit a distribution for the data. So let's run that, and as you can see, it shows the intercept, and then you have the scale which is fixed for 1, and then you have the Weibull scale parameter as 1 and Weibull shape equal to 0 because you wanted it to be a exponential distribution. Okay, and this distribution is actually also an extreme value distribution estimates. Okay, so to really understand these, if we go back to the SAS documentation for PROC LIFEREG, so here are the distributions LIFEREG supports. And in the model statement, if we specify distribution equal to exponential, yes, then it's going to fit a one parameter extreme value distribution. And the reason is that when we only fit, so in the distribution supporting the LIFEREG procedure below, if there's no covariates in the model, then mu is the intercept in the output, and sigma is the scale in the output. Okay, so if we cause the LIFEREG and the model and distribution exponential, then its survival functions, density functions, and the hazard functions look like this. And also the Weibull distribution. So basically we're going to have a mu, which is the intercept, and sigma, which is the scale parameter. And the reason why this is also an extreme value distribution is because there is a relationship between the Weibull distribution and the extreme value distribution. So if T1, T2, Tn a sample of random times of fail from a Weibull distribution, then if you take natural log of all these survival times from a Weibull distribution, then they become random observation from the extreme value distribution. Okay, so that is why we have here, we're both by asking distribution equal to exponential, we're forcing forcing the SAS to fit a Weibull distribution, and we forced scale equal to 1, so it's become exponential. And at the meantime, since it is actually a Weibull distribution, then it's also an extreme value distribution in this case. Okay, so here you can see the parameters fitted. So we only got, so this intercept would be the mu here, and the scale here, this is the sigma. Okay, so that's the distribution we fitted. And also, if you look at here, we didn't consider censoring. Okay, we just ignore it. Okay, so now this is a survival data that does have censoring, so we can fit the LIFEREG again, but using this syntax to take into account of the censoring, but we're treating it as a write censoring. So we do the same thing, so the distribution is the same. Now the intercept and the scale parameter for the Weibull are different. Okay. And similarly, once we fitted this survival distribution, we can actually produce the median or other quantiles, any quantiles you want, from this fitted distribution. And the way to calculate those quantiles is you refit the model, and then you use output to output the data into a new data set called new, and you get the percentiles, and you specify you want the quantiles 0.1, 0.2, and 0.9, and then you print out this data called new. And for the probability, that's a built-in variable, and then the percentiles. Okay, so if you calculate that, you can see the percentile for 0.1 is 1.7911, for 0.5 the median. Survival time is 11.7835, and the 90% percentile for survival time is 39.1439. And this is considering the censoring as write censoring. And we talked about LIFEREG has a strength for handling interval sensor data. So here's an example. We're reading a interval or double sensor data. So we have a small data set of upper, lower, and the X here. Okay, so we run it, we create the data set, and you still remember all the lower and upper bound means, right? So if we go back to the model statement, so if both are not missing or equal, means no censoring. Both not missing, the lower or less than the upper is censoring, interval censoring. Okay, the upper is not missing, but the lower is missing, and upper used as the left censoring, and etc. So you can refer to this table to understand what values we have here. Okay, so once we got here, then we can actually use this model statement, then parentheses lower comma upper equal to the intercept and distribution of the Weibull. So we're using a Weibull distribution, and a Weibull distribution is actually in the LIFEREG, the Weibull distribution is actually a so-called two-parameter Weibull distribution. So if you really want to get into the details, then you can go to see the formula for the LIFEREG. Details. So if you look at the supported distribution, you got the exponential, you got the Weibull down here, and it's determined by two parameters, mu, and this is the sigma, the scale parameter. Okay, and you can write it as this form, the gamma and alpha, which sigma is 1 over gamma and alpha is the exponential of negative mu over sigma. Then I think the gamma is called the shape parameter, and alpha is the scale parameter. Okay, so this is called the two-parameter Weibull distribution, and there is something called 3-parameter distribution. Then you have a scale parameter, a shape parameter, and a location parameter. So that's the most general Weibull distribution. And usually we assume the location parameter equal to 0. Then we ended up with only the scale parameter and the shape parameter. Okay, then it becomes a 2-parameter Weibull distribution. So you can spend some time to look at these, special survival time distribution. I think Lawless's book has lots of information on that. Okay, so if you use this set of code, then it's gonna estimate the parameters, but now you have a 2-parameter Weibull distribution. So you've got both the scale parameter and the shape parameter, and you still have the intercept, the term there. Okay, so now you have the you are still estimating the distribution because you don't have a covariance. Okay, but if you want, say, you know what the scale value is, or even you want to use this fixed intercept, you can just use that, say, scale equal to 0.5 and intercept equal to 1, and then use no scale and then no intercept. This way, SAS will use a 0.5 for scale and intercept equal to 1 as the intercept for the Weibull distribution. So now you have this newly fitted distribution. As you can see, the intercept is 1 and the scale is 0.5. Okay. Alright, so this is really a quick demonstration of how to use LIFEREG to fit survival or lifetime distributions.